So I'm going to move to the next one, conditional formatting. What is conditional formatting? Well, it's a way of, if you have a data set, and based on the condition that you've chosen, you can decide to format or color it separately based on the output that you want. So conditional formatting can help you make patterns and trends on your data more apparent. So you format it in the way you want to. So to use it, you create rules that determines the format of cells based on their values, such as following monthly temperature data with cell colors tied to cell values. Already formatting, so we can also come here and go here and say clear rules. Clear all select rules from selected cells. So you see we are fine now.
Okay.
So I think I already did some formatting before now. So we can go back again to our conditional formatting. We now go and let's take one other one. Date occurring, we don't have date. Duplicate values, do we have duplicate values? So let's try that. Is anyone with duplicate values here? Values with yellow. So let's see cells that are duplicate. So you can see we have 93, we have UK. You understand?
Yes.
So this is also very important. If you have I told you that there's a possibility when you have many people entering data into the database, there's a possibility that two people may enter the same thing if it wasn't well coordinated. I told you about the experience in our office where we were capturing secondary data on gender-based violence. So one of the things we discovered was that while a particular story could be reported in more than one national dailies, but our aim was to capture only one story that is related to a particular character, if you understand what I mean. So if the proper checking was not done and the papers are shared among different data entry officers, and you find one or two people entering the same story based on the fact that they will report one story was reported in more than one daily, so you start having duplicate data. So when you're analyzing this, you have to clean this data. You need to clean the data, or you'll be analyzing a lot of other things that will not give you the most accurate answer that you're looking for. So conditional formatting can help you to search through the entire range of cells to find ones that are duplicate, and that will help you to pull it out. Do you understand that? Data analysis, a more advanced way of analyzing data. This one is called descriptive statistics. Now, is your Excel document open? Is your Excel workbook open, or you are watching from mine? Are you watching from mine? Is your Excel?
Yes.
Okay. Now let me show you how we're going to get this done. Now, once you move from conditional formatting and you want to get into descriptive statistics, the button in your Excel that you work with is on the data menu, and it's called data analysis. If you open your
There's a button on the menu called data analysis. Okay.
Yes, but you will not see data analysis if you just open to your Excel document. It depends on the version of Excel you are using. Which version are you using? Is it 2013?
I didn't check.
Okay, so
I don't know how to check it.
Okay, fine. So if you don't see this button, normally it doesn't come by default. You have to add it to the Microsoft Excel environment. I'm going to show you how to add it. So for you to add data, so Excel has its own inbuilt data analysis button. So that's what we're going to use from now to possibly the end of the course for today. So if you don't see data analysis under data, so what do? The steps are: you click on File, you click on Options, and when you click on Options, you see Add-ins. You have to bring it up. Then you go to Manage Excel Add-in. You click OK. So once you click OK, you now have to check an Analysis Toolpack and Analysis Toolpack -VBA. These are the two you need to check. Once you check this and you click OK, then you restart your Excel. when you go to data, you will see data analysis. Do you understand that? I'm going to go through that process again. If you just open
Okay.
to your Excel document, you will not see data analysis inside data. So you have to add it in. Depending if you're using Excel version 2007, 2010, 2013, especially, even up to 2016, you will not see data analysis listed under data. So you have to add it to the Excel worksheet. So you go to
Okay.
File, you go to Options. From Options, you click on Add Ins. Then you see where you have Manage Add In. Click Go. Then when you click Go, check these two. If I uncheck this, the data analysis has disappeared. Have you seen that?
Yes.
So I'm going to bring it up again. So I'll go to File, Options. Then I'll click on Add In, Excel Add In. I'll say Go. Then I'll bring this up. Once I bring this up, and data analysis will appear. So the first thing we're going to do under data analysis is what is called descriptive statistics. So how do we get these descriptive statistics? If you click on data analysis, you look down here, you see descriptive statistics. So what does this do? This is what it does. Now, it automatically, based on the data you give to it, this is a score of, let's say, a particular student. Hello?
Yes, I'm here.
Let's assume that the student took exams and in different subjects, and this is the student's scores. So you can analyze this data using descriptive analysis. So I'm going to show you how this was done. So watch this. You see this thing that is put in here? I didn't type it manually. The system automatically analyzed the data to give me all these values you are seeing here. So I'm going to...
What did you not type manually? These ones that are highlighted?
Yes. I'm going to delete it off. So I'm going to cut this one, remove this. So I'll click on there. This is the note. So I went to data analysis. I went to descriptive statistics. I can remove label. I said the most important thing is the range that I want to work with. The column, I'll click on column. Then where I want to output the result, then I said summarize the statistics for me. Summary of the statistics. Then once I do that and click OK, this is what I have. So let's see what happens here.
Okay.
So let's see what the system is telling us here. So these values you are seeing here is coming as a result of what we have here. So first of all, it says the mean value is 81. So how do you find? I mean, it's like the average,
Yes.
The average of all this. If you add this together, then divide it by the number of subjects, that will give you the mean. So that's a good one. Standard error is 4.0. Median, middle number, is 85. Mode 95. 93. That's what mode is. Then standard deviation is this. Sample variance, kurtosis, skewness, range, minimum. The minimum score, the maximum score. Are you seeing that?
I'm seeing.
Then the sum, if you have to add all this together, this is what you have. Then count how many subjects? 14. So that's the statistics. So we've seen the statistics of all this. The system automatically works it out and tell us what what's happening here. By just choosing the descriptive analysis, the system automatically works it out and tell us what we have here. I want you to look at this number. Which two numbers here? Which number here is repeated?
Is 93 now.
So that's why we have what? The mode,
Yes.
The mode as 93. So we have the highest number, we have the minimum. So even if we are not going too far, we can say, oh, the average, this student's average is 81, which is good, and his minimum score is 58, while the maximum is this, So if we were to add together, that's what you have, and of course, out of 14 subjects. So that's a good one. That's what descriptive analysis helps you to do. So remember what we talk about under descriptive analysis. This is descriptive statistics. It tells you information about a range of data set that you have. Forward, we have what we call frequency distribution. This is very important in data analysis. If you have this table, this table has order ID, it has product, it has category, it has amount, it has date, it has country. I showed you how to format amount. If I click on all this and I go to home, I can pick this. This is called what? Command style. So it puts it in a form of a normal format for
money.
For our currency, I mean for money. So this is a country. I want a phrase sheet because there are too many things on that environment. So this is the table that we have. You are seeing my screen?
Yes, sir.
Okay. So you can decide to choose any item to find out the number of times that it occurs. So that's what frequency analysis does. So again, I said you will go to insert, we'll go to pivot table, then we'll select our range. So I'll click here, then I will now select from here to here. That becomes our range. Then I can also tell it to input this on a new sheet or on an existing sheet. So I think I'll rather put a new sheet. So when I click that, the system opens. You can see by default is there's nothing showing here. But on the right hand side, you are the one that will choose what you want to work with. So I'll choose product. So immediately I choose product, it shows all my products. Are you saying that?
Yes.
Then if I also choose amount, once I choose amount, it shows all my amount.
Yes, sir.
Now, but I want to know the number of times that these items appears. You can see the amount for apple is this, amount for banana is this, amount for beans is this. So it's showing the item one after the other. But if you watch on that table, there was some repetition. That means one country had more than one of these products shipped to their country. Do you understand? So we want to know the number of times that these products appeared on the table. So what do? You go to where you have sum of amount, right click on it, go to value field setting. So when you click on that, you can now choose any of these options to summarize the table that you have. We have summarize value field by. Choose the type of calculation that you want to use to summarize data from the selected field. I want to use count. So immediately I click on count. Look at what happens. The system automatically changes this to count. It's telling me that actually apple was shipped to 2 different countries. Banana was shipped to 2 different countries, to 3 different countries. Beans was shipped to 1 country. Broccoli was shipped to 2 countries. Carrot was shipped to 1 country. And orange was shipped to 1 country, making a total of 10 different attempts that were made to ship. That's what the frequency distribution table basically does. It shows you, it counts and shows you the number of times a particular item is occurring. Don't forget the way it was when it was amount. Everything was added up. For example, the banana that appears as 3 here in amount, this should present the sum of the total amount that was spent on banana being shipped to those different countries. Do you understand how it is? I hope you are getting it now. So let me repeat again. So what the frequency distribution table basically does is it gives you the frequency, the amount of time an item occurs. So it categorizes them, it brings them as one item. Now we have categories here, we have the products here. By the time these products are listed as distinct products and their sum are added together, you can find the number of times this product was shipped to different countries. How do we use this? You will see when we start analyzing data. Let me repeat again what I did. For us to find the frequency distribution for each of the products that are listed here, instead of you counting manually, for example, now I could have counted, if I want to do apple, this is how it's supposed to be if I'm doing it manually. So I can call this frequency distribution. Then I will now come here and write apple. When I write apple, and I say how many times did apple appear on this table, I'll type 1 2 1 2. So I'll say apple. Okay, I'll say product here. Then I now come here and say frequency distribution. Apple appear twice. Are you seeing that? Then I will now pick another product, maybe carrot. Carrot. How many times did they appear on the table? Carrot appears only once, so I'll type 1. So instead of me counting, so what happens if I have a very large table with thousands of data? How will I be able to count it manually? So the frequency distribution automatically helps you do that. So how do you do that again? I'm going to go through it again. You go to insert menu, you go to pivot table. From the pivot table, the range of table is already selected here. We don't want this one to be included, so we change it back to what? F11. I'll change this to F11. So F11, I'm changing from A1 to F11. Are you there? Hello, are you there? Hello?
Hello, sir.
Are you watching?
Yes, I'm watching. I dozed off a little, sorry.
Okay, you dozed off a little. Okay. Okay, maybe we'll be rounding up anytime from now. Sorry about the interruption.
Yes, yes, sir.
So A1 to F11, you show the range. Then you now open in a new worksheet, and when it opens here, you select the item that you want to specifically count, and you can now select the amount. So once you do that, you can now, the amount sum up is an aggregate of all the amount for each of the item. So you can right click on any one of them, go to value field setting, then say count this. The system will count it and repeat the number of times it appears on the table. That's what the frequency distribution table does.
Okay.
I hope that's clear. I will send the video to you. Then if you have this kind of table, this table is talking about the quantity of an item that was sold based on the unit price and the rate of advertisement that was done. Now, here, this is the dependent variable. If you remember, when we were talking about regressional analysis, we said there is a dependent variable, there is a non-dependent variable. So we want to see how the non-dependent variable affects the dependent variable.
Okay.
Invariably, we want to see if I am buying an item, if I put a price for an item, then I do a lot of advert on each of those items. I spend money on advert. We want to see how these two things put together will affect my sales, the money I will earn as a result of those things that I did. So a regressional analysis is a set of statistical methods used to estimate relationship between dependent variable, in this case quality sold, and one or more independent variables, price and advertisement. It is a reliable method of identifying which variable have impact on a topic of interest. The process of transforming a regression allows you to confidently determine which factors matters most, which factors can be ignored, and how these factors can influence each other. So in this example, the dependent variable is the quantity sold, while the independent variables are the prices. So between price and advert, we want to see which of these two items really had an impact on the quantity of sales that we had. We got that. So here I'm going to paste this. So I'm pasting this item, then we'll now go through it one after the other. So now I'm pasting this item, then I will now go to data analysis, I'll go to data analysis, then I'll look for regressional analysis. I'll click OK. That again. My Y range is this to this. And my X range is from, I click here, I say it's from this to here. Then my label is this, and my output is this point. So I'll click OK. So this is what you have. it automatically creates 3 different tables. It's calling this summary output, then it calls this regressional statistics, then it calls this ANOVA. ANOVA means analysis of variable, then it now creates the third table here. So what is the meaning of all this, and how can it help us in prediction in terms of the dependent and non-dependable variables? So let's return back here. So I will just read through this carefully. We can repeat it again when we meet the next day. So let me just tell you what each of this is. Let's start from here. So this is the analysis part. I've sent you the document. So based on the value that we have here, what is multiple R? What is R square? Adjustable R square, standard error. The R square equals 0.9. This is R square. The value of R square is equal to 0. So we are going to pick this data, read meaning into it, and understand what has happened, then make some prediction. R square equals 0.96. We have seen that, which is very good. Now, this shows that 96% of the variable in quantity sold is explained by the independent variables, the non-dependent variable, price, and advertisement. Do you understand that? The R variable shows that this is very close to 1. And when you have a value like for R square, which is close to 1, it shows a positive prediction, a positive output. This means that 96% of the variable in quantity sold is explained by the independent variables, which is the price and advertisement. The closer to 1, the better the regressional line fits the database. That's the first thing you need to know. So it shows that these two variables, the price and the advertisement, have a greater impact on what happens here. So if you fix your price is good, and based on the level of advertisement that was done, that is what is bringing this amount of sales that we have. You can see here something was 2 naira, but the quantity sold was 8,500. Something is 5 naira, quantity sold is this. So it shows that it has, based on this, there's a clear, the close relationship between those non-variable and that. Then what is this second one telling us? This second one is telling us that to check if your results are reliable, statistically significant. So when we talk about SS, we are talking about statistical significance. So look at significance if. Significant if is 0.001. If it is less than 0.005, you're okay. If significant if is greater than 0.005, it's probably better to stop using those set of independent variables. Do you understand what I mean? So our significant if here is far lower than 0.05. Therefore, what is telling us here, analyzing this means that those two variables that we are using as our non or independent variable, they are quite good. But if this significant if was anyway greater than 0.05, it shows that those variables will have to be dropped because they are not contributing anything to the high output sales that we have. Then we are moving to the third table. What does this table tell us? Now, 3, delete a variable with a high p-value. These are the p-values greater than 0.05. If there's anyone that is greater than 0.05, delete it out. So whether it is pricing or whether it is advertisement, anyone that has a value greater than 0.05 should be deleted, and we should rerun this until we have something that is below 0.05. Coefficient. The coefficient line is, so this is the formula. So the regressional line, the formula that we're using to get this value is y is equal to quantity sold. Quantity sold is equal to 8536.214 8536.214 minus 835.722 times the price plus 0.592 times advertisement. Now this is the
formula.
The formula is gotten from the table here. 8 8536 minus, see, 85, this is what the system generated for us.
Okay.
These formulas are gotten from here, from this coefficient.
Okay.
8536 minus this times price plus, don't forget, these are the two variables, price and advertisement. Plus 0.59 times advertisement will give you the quantity sold. So this two has something to do with, this phase 2 has something to do with price, while this one has something to do with advertisement. So this minus this times the value of your price plus this times the value of your advertisement will give you the quantity sold. So if we fix in the value of price and the value of our advertisement, then we will have the value for our quantity sold based on what the system has detected for us. In other words, I'm going somewhere, I want you to see this. In other words, for each unit increase in price, quantity sold will decrease by 835.722 units. That's what we've seen here. As the price is increasing, this one will drop by this amount. So as you're increasing your price, the quantity sold will drop by this amount. So, but for each unit increase in advertisement, quantity sold will increase by this. So when you increase this, so as you spend more money in advertisement, the quantity sold will increase by 0.592. This is a valuable information. We can use these coefficients to do a forecast. A forecast is prediction. So what does that mean? For example, if the price equals 4 and advertisement equals 3,000, are you seeing? Then you might achieve a quantity sold of this minus this times 4 plus this times 3,000. That will give you 6970.